Alright, so welcome to the episode 2, and in this one we'll be understanding how Amazon tracks billions of packages in real time. So you might have ever, at least once in your life, have ordered something from Amazon, and when you open the application, you watch your package move from preparing for shipment to out for delivery. And it feels very simple. If you were to go and ask some individual how does that work, they would simply say the warehouse maybe scans the package, then the truck picks it up, the Amazon updates your application, and that's it. But the crazy part up here is Amazon ships more than 20 million packages every single day. So if every single package is scanned dozens of times, like for example, it moves through a warehouse, one scan, conveyor belt, another scan, airplane, another scan, delivery station, another scan, doorstep, another scan. So that is like hundreds of millions of scan event every single day. So how does actually Amazon keep track of all of them without making its system suffer? Now, most people would imagine a giant database where every single barcode is scanned, update the package location, but imagine millions of scanners trying to update the entire database, like the same database every single second. That becomes the bottleneck. You cannot do that. That's not just how system works. So what does Amazon do? How does Amazon solve this problem? So Amazon basically treats every single barcode as an event, and those events flow through a massive event driven architecture where different services process them independently before your tracking page is updated. And that's only the beginning. By the end of this video, you'll basically understand how Amazon combines event streaming, finite state machine, graph databases, and the CQRS to track billions of packages in real time. So let's understand first from the very first step, which is inside the warehouse, because it all starts inside the Amazon fulfillment center. Now, you might all think that all the laptops are stored together, all the books are stored together, all the soap or conditioners or anything like that are stored together, cosmetics are stored together, but that's not how Amazon works. Amazon uses something which is called as chaotic storage. So items are stored wherever there are space available. So a laptop could be sitting beside, let's say, dog food, or a novel could be sitting beside, let's say, a coffee mug. At first, that sounds really, really disorganized. So how does Amazon ever find anything? It is very simple. It does not remember where the item is, but it remembers where the barcode is. So every storage bin, shelf, maybe robot, a pod, or a tote, every package has a unique barcode, which is often called as LPN, license plate number. And as long as every moment is scanned, Amazon always knows that where the package currently is. Then the second step comes in where every scans become an event. Now I want you to imagine a robot which moves on a storage pod, or a worker that scans a package, or an automatic scanner that reads a box moving on the conveyor belt. Each of those actions create an event. So a robot comes along, scan, titit, event. A worker put the box on the conveyor belt, titit, one more event, something like that. As simple as that. So instead of writing directly onto the database, those events are first sent to event stream using systems like maybe Apache Kafka. I think Apache Kafka is the one that Amazon uses, yeah, or maybe Amazon's own internal streaming platform. I'm not very sure, but most probably it's Apache Kafka. Why does Amazon do that? Why they just collect everything once and then do it later? Why? Because thousands of scanners can keep working without waiting for the database. So the scanner can simply publish an event, and other services consume those events and process them independently. And that is one of the biggest advantage of event-driven architecture, because the warehouse keeps moving even when other servers are temporarily busy. So let's say, for example, that the database is not working. Even though if the database is not working, every single event can still be stored, can still be collected, can still go on. That is the power of event-driven architecture. Then comes the act number 3, which is turning events into a tracking update. So a barcode scan alone does not tell you very much. A barcode scan TT, what does that tell you? TT? So Amazon still need to answer the questions like, has the package been packed? Was that TT of packing? Was that of truck? Has it left the facility? Is it out for delivery? And things like that. And this is where 3 important software engineering concepts come in. The first is finite state machine. So every single package follows a fixed life cycle. Order place, allocated, picked, packed, in transit, out for delivery, and then delivered. Yeah. So the package cannot randomly jump from placed order to delivered. No, that's not how it works. Even in Uber, that's not how it works. You just you place an order, the driver picks it up and then delivers it, something like this. So basically you understand the idea that you cannot place an order and next moment have it delivered. No, you have to go through the process of it. So the finite state machine enforces these valid transitions. So even if and scan event arrive out of order because the network delay, the system uses timestamp to sequence number to determine the correct state right here, right now. Let's say for example that there is an error and some suddenly after picked it says out for delivery. No, that's not how it works, because the timestamps now know, okay, it was picked but out for delivery. No, it is not even being packed or not in transit, so maybe there's an error. So that's where we know, that's where the Amazon's algorithm knows, that's where the system knows that there is some problem. Then second component is graph database. So packages does not travel randomly, they move through a network. First of all, they go through a full fulfillment center, sorting center, air hubs, and then delivery stations. So the network naturally looks like a graph, like a node graph. First, second, third, fourth. So each facility at this point becomes a node, and each transport route becomes an edge. So a graph database helps Amazon understand the best path through the network and quickly adapt when the route changes because of maybe weather, delays, or capacity constraints. So it is kind of very similar to Uber delivery. If you have watched that episode, then you might connect the dots. If you haven't, then just go and watch it once and then come back on this one, or maybe watch this one and then go back and watch that one. You will connect the dots between both. Then the third and most important constraint is CQRS. Millions of warehouse scans are happening every single minute at the same time. So millions of customers are opening Amazon to check where their package is. So if both operations use the same database, they would compete with each other. They would just say, oh no, me. Okay. So instead, what Amazon basically do is they use CQRS, which stands for Command Query Responsibility Segregation. So the warehouse writes event on the command side, and the background service processes those events continuously and build a real model optimized for customer tracking. So when you refresh your Amazon application, you are basically reading from the fast pre-built view, not the live warehouse database. So it's basically keep on updating, and it's a pre-built view. So whatever has happened already a few minutes ago, that is what you're seeing. You're not seeing very live, and that's why the entire tracking feels so instantaneous. I just learned that word. I don't know what the fucking means. So even during your peak shoppings, Amazon just gives you every single update perfectly. So that's how it works. So thanks for watching. If you liked it, then maybe click the like button. If you have any questions or if you would like me to make any breakdowns, then just comment it down and make sure you subscribe to me. Yeah.